Welcome to WERMZ Energy Limited. Today, we are going to explore the installation of a PWM charge controller with 6 solar panels connected in parallel. Each panel is 250 watts and we will show you how to connect them to the charge controller and battery. Let's start with the solar panels. We have 6 panels, each with a rating of 250 watts to increase the current output because we are using a PWM charge controller. We have connected them in parallel. This means we will connect all the positive terminals together and all the negative terminals together. The PWM controller has terminals for solar panels and batteries. On the solar side, you will see positive and negative with the symbol plus and minus markings. Connect the positive wire from all the 6 panels to the positive terminal and the negative wires to the negative terminal. On the battery side, the charge controller also has positive and negative terminals with plus and minus markings. Connect the positive wire from the battery to the positive terminal and the negative wire to the negative terminal. If you are new to the solar installation, comment below with questions. Like this video if you're learning something new and subscribe for more solar energy tutorials. Share with friends who might benefit. You've seen how to connect 6 solar panels in parallel to a PWM charge controller. Make sure you watch to the end of this video and please don't forget to hit the subscribe button. Now let's dive into the site installation.
Hello and welcome to my channel. So today we are setting up a 2 kVA transformer based system, and we're using an external charge controller PWM precisely. So as you can see here, these are the ratings of the solar panel. As you can see, 250 watts, the optimum operating voltage 30 volts, and the open circuit voltage is 45, and the amperage is 8.22. So I think with this and knowing the kind of the charge controller that I'm using determines if I'll be doing my connection in the series form or in a parallel form. So since we are using a PWM charge controller, I'm going to parallel all the solar panels. So stay tuned. Okay guys, so as you can see, I'm just setting up my panel frame. You can call it panel frame or you can still call it interlock, but majorly this is the interlock panel holder. Call it panel frame, panel holder, interlock, any of them. So this is it for my 6 panels. This one is on the other side of the roof and this is on the other side of the roof. So stay tuned. Okay, so I'm done with the panel connection. Like I said earlier, I paralleled all these 3 and these 3. So what I did here was just parallel connection due to the fact that we are using an external charge controller, who is a PWM charge controller precisely, not an MPPT. So since we are using a PWM charge controller, I paralleled all of them, as you can see. And this is where all the positive terminal came to, and this is where all the negative terminal came to.
Now, let's explore the breaker box and PCB components that protect and control your solar energy system. These components are crucial for ensuring the reliability, efficiency, and safety of your system. First, we have the surge protective device known as the SPD. These critical components protect your system from voltage spikes and electrical surge, which can damage your equipment. You will find live, neutral, and ground connections here. The SPD ensures your system stays safe from electrical surge, thereby preventing damage to your inverter, charge controller, and other sensitive components. It's essential to note that SPDs are designed to protect against transient overvoltage, which can occur due to lightning strikes, grid switching, or other external forces. Next, the single pole DC breaker handles the DC power from the solar panels. This is the first point of connection for the panel output before it reaches the charge controller. If there is an issue such as an overcurrent or short circuit, this breaker trips to protect your system. It's essential to size this breaker correctly to ensure it can handle the maximum current output of your solar panels. Additionally, DC breakers are designed to interrupt DC current, which can be more challenging than AC current due to the absence of a zero crossing point. The voltage regulator is crucial for stable voltage output. The input, known as the in, connects to the building's distribution box where you find the live and neutral wires. The output, known as the out, goes straight to the inverter for charging. This ensures your system gets the right voltage, typically from 190 volts to 250 volts, depending on your system design. The voltage regulator also helps to prevent overcharging, which can damage your batteries. Furthermore, the voltage regulator can be designed with various features such as overvoltage protection, undervoltage protection, and temperature compensation. The AC breaker controls power to the voltage regulator. When turned off, the voltage regulator shuts down. When turned on, it activates. The live wire from the distribution box goes through this breaker before reaching the voltage regulator's in live terminal. This allows you to control the power supply to the voltage regulator and inverter, making it easier to perform maintenance or repairs. It's essential to note that AC breakers are designed to handle AC currents, which can be more forgiving than DC currents. Note, the SPD protects from surge. The DC breaker handles panels output. The voltage regulator ensures stable voltage, and the AC breaker controls the regulator. Understanding these components keeps your system running smoothly and efficiently. It's essential to properly size and configure these components to ensure reliable operation and maximize the lifespan of your solar energy system.
Okay, guys, so I'm done with the whole connection. Like I told you earlier, since we are using a PWM charge controller, I paralleled all the solar panels, and this is the charge controller here, and these are my breakers. This first one here is known as the SPDC. This is a breaker for the panel in case of anything. This is my voltage regulator in case of high voltage or low voltage, and this is my AC breaker for this voltage regulator, still for protective measures. And this is my inverter inputs, and these are my load. This is my AC inputs. This is my neutral, negative, and this is my life. So if you have any question, just drop a comment. And this is the inverter Empower product. This is a 2.5 kVA system. As you can see, this is a pure sine wave 2.5 inverter. This is a transformer base, and these are the battery, 24 volts tall tubular battery. Each of the battery is a 12-volt battery. So what I did here, I just series the two to give me 24 volts. This is my battery. As you can see, the work is neatly done and everything is working. Yeah, it's good right now. That is why this voltage regulator is on. can see the voltage of the grid fluctuating between 206 and 205. It's quite okay. And the number down there, 2.2, is the amperage. Okay, so I'm done with the full setup of the 2.5 kVA transformer based inverter. So as you can see, the work is neatly done. These are my breakers and this is my charge controller. This is the inverter itself, and these are the batteries.
Thanks for watching, guys. We are glad you got value from this video. We appreciate your time and interest here in the solar world. Stay tuned for more informative videos and don't hesitate to reach out with any questions or topics you would like us to cover. Please like, comment, share and subscribe for more content. See you in the next video.